and then it would be on the UG2 YouTube page if you want to access it. Afterwards, if you have some questions that are that you know that were discussed right now that you want to get back to, or if you want to show to your colleagues, so it will be available on the UG2 webpage. The presentations will also be stored on the Ego website with the other ones, and that means that even if you have some colleagues that could not join, you can still they can still access it, and can also contact us if you have any questions after, and I can be the contact point. There is my mail on the top right, on the bottom right, and I can spread the questions to the right person, so you have some answers.
And I can add, Yves, that the list of all webinars, UG2 and Ego, are displayed on one of the Ego pages. So you can look at all the same webinars if you wish. So.
And all the presentations are there. So today is our 4th webinar, and there are 3 that are already stored on the website. The next event from UG2, like we're working on a combination, is just a reminder for the UG2 workshop in September. That would be in person in the US. So if you want to connect, and I'm sure you already had some information about that, but just a reminder. I think we can start with 29, maybe wait for the 30th person. I will just say a few more words. We have this session, we only have two presentations. The goal is to be as interactive as possible, as I said. So we'll have time for some Q&A at the end. I don't know if it really call a Q&A or just a session to discuss. But we will start with Thierry Carval, that is the leader of Coriolis, that will present the Coriolis Glider DAC activity. And then we have Victor Turpin, that you must already know, that will present a tool that is hosted on the Ego website to produce some metadata JSON files. So without further ado, if anyone wants to have a small comment, I don't know, just raise your hand. If that is okay, I see that everyone is silent. So I will leave you the floor, Thierry, and to present all the great achievements that you have in Coriolis for the glider community. And
I try to share my screen. Full screen share.
Meeting workshops.
Sorry, these are my notes. So do you correctly see the presentation?
Yep.
Yes,
no,
so 20 minutes for Coriolis Glider Data Assembly Center activity. So I will start to give an overview of the context. So we are part of Ocean Gliders, which is the glider component of the GOOS, the Global Ocean Observing System. The Ocean Gliders program brings marine scientists deploying gliders from all over the world to observe long-term physical, biochemical, biological ocean processes and phenomena. And in terms of data management, one of the goals of Ocean Gliders is to address gliders data collection and support the dissemination of glider data in global databases in real time and delayed mode. So in real time, typically to operational centers or to directly, and in delayed mode to the scientific community. Ocean Gliders recommends to develop a global operational program for underwater gliders to address key ocean observing challenges. And the second point is very important for data managers. It's to develop a global data management system to ensure the effective sharing and use of data from gliders. And the Ocean Gliders key area of ocean observation are ocean boundary currents, the storms, and water transformation. And the objective is to have a sustained observation of these key areas. In terms of data management at Ocean Gliders, so at the global level, so Ocean Gliders addresses a limited number of scientific issues and focuses on some EOVs, essential ocean variables, observed in national, regional glider places. And we want to harmonize the data management, but on a global scale. So there is an Ocean Glider Data Management Task Team, OGDMTT, that develops a strategy and implementation plan for international coordination, and governance. And in this activity, important topics are to merge or to have a seamless management of near real-time data and delayed mode data streams, harmonize the quality assurance and the quality controls applied on the gliders data, address biogeochemical data handling, and as we are Coriolis, we are very much involved in OneArgo, the global profiling float program. And our wish is to have Ocean Gliders and OneArgo working in parallel and with similar methods in terms of data management and probably in terms of quality control and QCs. We want to standardize. We make efforts to standardize formats, protocol, provide data access, fair, open data access through web services and typically API. So this is a joint activity from already existing programs or network or projects such as Ocean Gliders Canada, Australian National Facility for Ocean Gliders, so ANFOG, the US National Glider Network, IU's National Glider Assembly Centers, and Everyone Gliding Observatory, and other group willing to participate and to construct the ocean gliders. So EGO, Everyone's Gliding Observatory, is we can say that this is the European contribution to ocean gliders. So Ocean Glider Task Team is working quite hard, and during the last year there was a lot of work, and that delivered successfully a unified data format to facilitate the sharing and collaboration of data. So we did harmonize the 3 existing standards, US, Europe, and Australia, with minimum impact on historical data, but flexible and stable enough for long-term usability. And we want to match as closely as possible BGC Argo Float and Ocean's mooring data management. So here is an important link. Go and don't hesitate to participate on GitHub, where you have the Ocean Glider data management activities that is managed here, and it's very active. And the big topic is on the format user manual. And now we have a version 1.0 of the manual, and the manual that describes the metadata and the data. And aggregated into netcdf file format. So here you have the most recent version of the user manual that describes the version 1.0 of Ocean Gliders format. So what is contribution of Coriolis DAC? So Coriolis DAC is for more than 10 years now. Coriolis DAC contributed for a common netcdf CF format to manage glider metadata and observation organized by deployment. So we have Ego Gliders netcdf format manual, which is active, and we improve it regularly. And our next task, and I hope that by something like autumn this year, we'll be able to provide the conversion from the Ego Glider netcdf format into the Ocean Glider 1.0 format. We apply the series of quality controls in the netcdf files of the glider we do manage. So it's a series of 16 quality controls derived from Argo real-time quality control. So this is documented here in this document. And if you want to have this document, you simply click here to get the full text, and and you click here on download, and the latest version is the version 1.4.0 that was updated in 2022. We distribute our data processing chain. So this is the link if you want to download the data processing chain. So it's regularly updated. The latest version is from October 2023. And with this data processing chain, you have a compiled version of MATLAB code. The data processing chain is a MATLAB code. It's something like more than 100,000 lines of MATLAB code. And it is compiled so that you can use it even if you do not have MATLAB on your side. You do not need to pay a license. It's executed. The compiled version of our MATLAB data processing chain is compiled into a Java code, and you can run it, download it, and run it on your side. And we have a well, no, I won't talk too much. Say some more, but later maybe. We also have a very important piece of code, which is the netcdf file format checker that is checking different type of formats, among them the Argo Float, the Copernicus Marine Institute netcdf format, and Ego Glider netcdf format. So the file format checker is very important for the data assembly center activity. When we receive data from outside that has already been assembled as an Ego netcdf file, we apply the file format checker, and we have an immediate report saying that yes, the file is compatible, or no, it's not, or there are warnings, so the file is okay, but some warnings and proposal for improving some part of the netcdf that we receive. So what is the activity of a data assembly center? So this is the case for Coriolis, but it's also probably the case for other data assembly centers. We first have to receive the glider metadata in JSON file. JSON is a format that is very convenient to it's human readable, but it's also machine readable. And so it's very convenient to to describe all the metadata that we want to put in our system. Then, very important, it's also the glider data coming from the glider as Iridium messages, but I should update my slide here because in real time it comes as Iridium messages, but when the glider is recovered, it comes as original glider files, and we can manage this kind of files. So I need to add this here. So both the JSON files and glider data are processed by the data processing code and to generate glider deployment netcdf, one trajectory file per deployment, and derived from these trajectory files. It's not additional, it's derived. We extract from the trajectory files many profile files, vertical profiles, and this is typically for our operational users. On these profiles are sent on the GTS. The GTS is the World Meteorological Organization network. And it's also sent to operational users such as Copernicus Marine Service and the scientific community also. The specialist will use the trajectory files, but people wanting to have a view or an understanding of the water column will probably prefer the profile files. And so the netcdf trajectory contains data, metadata, and the QC, quality control flags of the glider deployment. A tricky task, it's to manage the metadata of a glider deployment. So I told you that this is done in JSON files. So a glider deployment metadata are managed in JSON files. And for each deployment, it is a combination of one metadata file that describes the glider mission, and there is one metadata file per sensor. And there can be, if you have 10 sensors fitted on your glider, then we expect to receive 10 metadata files, one per sensor. The JSON files can be created from a web interface, and this will be presented later by Victor. Or you can simply copy, paste, and update from previous deployment or from other deployments. What we want to do is to manage the deployment JSON files, whether they come from the web interface or whether they have been processed or created manually on Git, so with GitHub or GitLab. So the idea is to create a ticket for each deployment. So this is for the DAC and technical team interactions, and it will save a lot of email exchanges and so on. Everything will be, the idea is to centralize everything into a ticket for the deployment. And the JSON files are to be managed on Git. So an example, let's have a look at the C49 deployment of, it's a glider that was deployed very recently in July, on the 10th of July, 2024. So let's have a look at the ticket that is associated to this deployment. So do you correctly see this web page? Should I zoom in? Yes, okay, so if it's okay. So the ticket is for this deployment, and this deployment is a deployment of a Sea Explorer glider. It was deployed in July 2024. The scientific, the principal investigator is Xavier Durand de Madron from Université de Perpignan. And let's have a look at the configuration files. So the JSON files that are absolutely needed to perform the decoding. So you see here that it's a mission where you have an echo fluorometer fitted on the glider and a CTD. And so let's start with a look at the general configuration of this deployment. So here is a JSON file. Most of you probably have an idea or already use JSON because it's very very common in data management systems. So you see a series of information concerning this deployment and the glider itself. So the first variable is time, and we shall read the time in a variable coming from the glider that is called PLD real-time clock. The latitude and longitude will come from a glider variable that is called nav latitude. So this is something, these names are used by the glider. And there is a series of metadata information here, where you see that the platform time is C Explorer, that the serial number is C049, the glider owner is CFRAM, the positioning system, the transmission system, and some very important...
Five more minutes.
5 more minutes, okay. So the deployment will start, the deployment start that, and the deployment was performed at this latitude and this longitude, and additional metadata such as presentation of the experiment. So second file, let's have a look at, for instance, the fluorometer. So the fluorometer is here. You have configuration here, a series of parameters that will come from here, and the units, and important, it's here, the combination. This variable that comes from the glider is the fluorescence chlorophyll A. This variable that comes from the glider is the CDOM variable. And this variable is the fluorescence CDOM. It's the association between data from the glider and the vocabulary we use in our data system. And sorry, here I don't see. Okay. And I'm back to the presentation. So we now operate a prototype of GDAC, Global Data Assembly Center, that is aggregating data from various data providers. So the glider data is available from HTTPS, from this address. In AirDAP, there is also an AirDAP server that is available here. And the GDAC is organized with a directory per glider and a subdirectory for each deployment. Each deployment contains the netCDF trajectory data and metadata file, the deployment JSON file, a directory for all vertical profile, and one netCDF file per profile extracted from the netCDF data file. And let's have a quick look here. Here is the data from this deployment on the GDAC. So you see that there is one directory for the glider, one directory for this deployment, one netCDF file that contains the trajectory and the metadata, and one directory that contains all the vertical profiles that have been extracted from this trajectory. And if you want, you also can, we provide a data discovery service where we show the presence of the glider. So this is C's glider. Let's have a look at the last 30 days of this glider, and we see that it has been deployed around Perpignan and is evolving in the Gulf de Lyon, in the Mediterranean Sea. So there is, well, I will skip. I think that we have a work underway for data citation to assign DOI for each deployment, but I don't have much time to talk about it. But that's an interesting activity we have. and a global look at what we have at our prototype of GDAC. So we are funded by Copernicus Marine to aggregate data from glider profiles from ocean gliders and GTS. And today I made some counts, and we already have 3.4 million ocean vertical profiles from 577 gliders. 95% of them are ocean gliders, and the rest is data, glider data that we received from GTS. A few maps just to finish, to what are these 3.4 million profiles. So here they are at the global level. So from almost 600 gliders. And here is a focus on the Atlantic Ocean, a focus here on the Mediterranean Sea. And there are huge quantities of deployment managed by our US colleagues here, and you have a focus here in USA on the East Coast. And that's all. Did I finish in time, or maybe?
It's good. It's good. Thank you very much, Thierry. That was really interesting. And I hope there is one or two questions. Great presentation, Thierry. And there's a comment, but there's a question from Emma, or at least a hand raised.
Hi, Thierry. So it'd be interesting to know how you're going to convert from the Ego file to the Ocean Gliders file. I'm just wondering, because we've added some extra metadata within the Ocean Glider file. We've added some extra control vocabularies, and so I'm just wondering how you're going to tackle that.
This is in our to-do list, and I hope that we'll be able to provide somewhere in October to have this conversion. And yes, do you think there are, well, if it's additional information on vocabularies, as we used as much as possible the Argo vocabularies, I hope it won't be that difficult with the support of the NVS to make the link between our Ego NetCDF and the OG1 metadata format.
Yeah, I guess we'll have to go through the mandatory variables and then see how we can map them from the Ego. I guess a lot of the Ego file had the reference tables, and so wasn't actually linked to any controlled vocabularies. So I guess we'll just see how we want to manage that for legacy ones. It might not be possible for all of them. That's just, it might not be.
I would be surprised that it won't be easy, of course, but I would be surprised that we find incompatibility. I don't see why we would have a major problem.
Let's hope for that.
I'm confident. So.
That's good. Yeah.
Thank you, Thierry, for this nice presentation. I have a few comments. First, on this map, it looks to me that the Australian gliders are not very present there. Can you explain that?
Yes, that's also in our to-do list.
Okay.
High in the to-do list. Our Australian colleagues make their data available from AirDAP server. So as we did for US colleagues, we want to harvest regularly data from Australia from the AirDAP server. Or if ready, from Ocean Glider DAC, but in our short-term plan is to not to contact, but to harvest, because the data is available on AirDAP.
Okay, thank you.
And also, if you go a little more northern, you will see that we certainly miss public data that are available from Japan, from Korea. So yes, some work needs to be done and some contacts needs to be developed.
And then it's more a comment, and I would like the backup of the community here. When you, in the converter from the data files to the Ego or Ocean Gliders format is not really suited for real-time operations, because it processes everything every time you launch it. So it's a bit long to process, and it's not really fast enough for the piloting operation, I would say. And it really limits, I think, the use of this converter and the development of tools to pilot and operate gliders. So do you have a plan to make it, to optimize it in such a way the conversion could be much faster? Probably we can ask for the community to,
yeah,
if they agree with that. You back me up or not?
If you say you should improve your system or your software, I cannot disagree. For data management point of view, it's not that that important, because if we can manage data of a glider once a day, or no, it's better to do it 4 or 5 times a day. But I guess that what you mentioned is more to have directly the data, or directly direct control for piloting, no?
Yes.
And so the data assembly center activity is not to provide this kind of piloting services.
It would be another objective.
No, or some part of the
life of everybody to have that. So
we as data manager, we want to produce NetCDF files that are fair and that can be distributed and available by everyone. But for piloting, it's a step before, where you don't need to distribute NetCDF with all the metadata and so on. You need direct access where from what has been sent by the glider, and so some part of the code used by the DAC might be useful for the piloting, but these are two different software, I think. That's my opinion.
Okay. Emma, if you want to quickly contribute to this discussion, then there will be a very quick question that Felix put in the chat that I can read, and then we'll move on to Victor.
I was just going to mention that at the so we held a workshop at the International Glider Conference in Sweden recently. One of those breakout sessions was about piloting metadata and what metadata might be useful when you're doing delayed mode QC. So I think it is something that, you know, there could be useful information from the piloting logs that we might want to bring forward. Obviously, it's a bit lower down on our list. We've just released the Ocean Gliders format, the next kind of priority on our list is looking at how we get that adopted, the workflow between the DAC and the GDAC. And so hopefully we'll have some discussion soon about that. And obviously we want to make it easy for people to adopt the Ocean Gliders format. So we'll be doing some consultation.
Okay. Thank you, Emma. So the question from Felix here, his mic is not working. How is data from other sensors not QC'd by Coriolis put in the netcdf file? Is it only the raw data from the Iridium message?
So I'm not sure to understand, but what I understand is that on a glider, you might have some sensors that do not transmit their data in real time. And so we have, when the glider is recovered, we later have to get the data from this sensor and merge it into the system to produce to add this data into the netcdf trajectory files. Is that correct? And yes, this is the work this is the functionality and this is an activity of the data assembly center.
Okay. I'm really trying to focus to stay into 1 hour. We're already 40 minutes. Maybe you can put the questions on the chat and continue the discussion. I think that this topic could last for hours and hours, but I'm afraid that if we continue, Victor will not be able to present. So sorry, Tonga Prakash, I don't know if it's the name, and you can put the question on the chat. Sorry for that, and Victor, I leave you the floor.
Hi everyone. So I will share my screen and try to share the video. Yves, I'm a bit scared if this doesn't work. Maybe you launch the video and we'll
Okay,
organize
it will work.
Yeah. Okay. Can you see a black screen?
Yep.
Yes.
11 minutes 12.
Perfect. So before I start, I would like to say that this webinar aims at really introducing to this metadata form developed on the IGO website to support the data and metadata flow to Coriolis DAC and OceanOps. As Thierry said, the management of the metadata for the processing chain used by Coriolis can be complex, and we faced that in the past, and we have developed this tool to facilitate users to manage those metadata and push the information to Coriolis. So basically, this form is useful for the users of Coriolis DAC at the moment, but for the current users and the future users. So we will be looking at the video that is available on the website, and I will try to comment on it. This is a kind of new exercise for me, so please be tolerant with me. So a quick word on Ego. It will be very fast. Ego provides support for data management as a single entry point, and also a link to the Eurogoose Glider Task Team, Ocean Glider, etc. Why would you like to register your glider deployment? First, to make it findable, accessible, interoperable, and reusable, to contribute to Goose, to contribute also to regional organizations like EOS, to contribute to Copernicus, Edmodnet, SDataNet, and advertise your activity to the community. So the strategy put in place is the following. You need to set your environment on the IGO website. Basically, it's having an account. And then when you have a new deployment you want to share, you fill a form for metadata. And from this, it distributes, IGO, the website, will distribute the metadata to Coriolis and to OceanOps, and this will be distributed afterwards to CDataNet, Copernicus, EMODNet, OceanGlider, Goose, and WiGOS. So the idea is really to facilitate the flow, the access to all these European and international organizations, I would say. Yeah, and this is absolutely this is a tool useful if you don't have someone that is doing it for you. I mean, a DAC. So to access this form, it's pretty simple. You go on the EGO website and you click on this button here, register your deployment. If you're not logged in, you need to create an account. Again, it's pretty easy. You create a username, a password, an email, and you get your credential, and you can afterwards access to this form. So this is how the form is organized with different sections that are totally in line with what Thierry showed previously. And you can start filling the different information. So we'll do that together to show you the functionalities. Before we start, it's important to say that on the left, this I would say the human readable value, and on the right, it's how it's written in the JSON file. So we did that because we realized in the past that there was misunderstanding in the name of the different field. So we think it facilitates the reading. When there is an asterisk in the file, it means the field is mandatory. And when you hover your mouse on the different fields, you'll get a detailed definition of this field. And then you can start filling your form. So the glider name is I mean, if it's a new glider, you enter a new glider name, but if it's an existing glider, then you'll find it in the list. The name of the deployment, there is no rules on the name of the deployment. A WMO number. If you have a glider and you want to share the data, you need to get a WMO number. This is a unique identifier for the glider. And if you and to get this WMO number, you need to request it on OceanGlider's website. You fill the data assembly center. As I said, this form is made mainly for Ifremer, but there are also other data assembly center. You fill the PI. If the PI is in the list, if the PI is already in the list, you don't need to fill any email. If it's not, you have to add the email. And then a project and what we call an observatory to say locate the glider deployment easily. Then you have another section on glider characteristic. Here you have only mandatory fields. You need to get the platform type. So you have different type of gliders. If you don't know if your glider is, for instance, Slocum G1, G2, G3, just pick the generic name. This list is maintained by OceanGliders and OceanOps, and it will be added with new values in the future. Then you have the serial number, the owning institution, and the operating institution. Quick word on the owning institutions. This has an impact on what we call the glider group in the management of the users of EGO. This may cause some issues, but in 80% of the cases, there is no big deal with the owning institution and the glider groups. Then you fill the deployment information. So the operator is not mandatory, but you can fill it. The status of the deployment will inform EGO that the deployment is in the future, is active at the moment or it's in the past. So this is not mandatory, but very useful for the maintenance of the Ego database, if I understand well. And then here are the deployment start information with the date, latitude in decimal degree, and longitude. It's also we put the end date, the planned end date mandatory because of the difficulty to manage and maintain the database up to date. Sorry. Latitude and longitude are not mandatory, and you can leave it empty if you like. So this is for the deployment information, I would say. And now we enter the sensor part, which is the more complex part. And we realized in the past that this section needs some tools to for the users to fill the information in the metadata file. So here you need to select the sensor family. I will take the dissolved oxygen sensor family, which is probably one of the most complex case. And I pick the Andera Optode 4330, which is a very common dissolved oxygen sensor on gliders. So now you have selected your sensor, you need to add it in the list, like when you put it in your cart, when you buy stuff. So you click plus here, and the sensor is now in your glider and associated to the deployment. You need to fill some metadata here. The serial number of the sensor is mandatory. And we also request a calibration file because we realize that without calibration coefficient, it's not possible to use the data in delayed mode and sometimes in real time. So we decided to ask for the calibration file, which can be a bit overwhelming sometimes, but it will change it's really a game changer in the management of data. So yes, serial number, calibration file. I wanted to say something else, but I can't remember. So I let the video, I was a bit too fast. I let the video move, and then you need to select the parameters. Here it's also something we faced in the past, that users have difficulty to understand what we call the ocean glider variable name and the glider variable name, which is different. So we need to map what the glider is sending on the land station to the standardized name used by Ocean Glider to manage the data. So this is what we are doing here. For instance, the Optode has many parameters, can deliver many parameters like B phase, C phase, count, doxy, D phase, etc., depending on the configuration of your sensor. So what we've done is we have reviewed everything from the past we had in the different database, and we try to identify this sensor, the Andera Optode 4330 on a Slocum, can deliver this Ocean Glider sensor parameters, and how it is named in the file is on the right. It's called glider variable name. This is what the glider is sending to you. So for instance, the C1 phase doxy is named SCI_oxy4_C1RPH. But sometimes we don't have values, so you'll have to edit this value yourself. through this tool, and this is what we will be doing here. If you click bphase, that has no existing value yet, and then you enter the variable name sent by the glider. So this is how you make this mapping between what the glider is sending, the information, and the name it's sending to the name of the ocean glider variable. So it may be a bit complex, but it facilitates a lot the management of this information. And when the form is filled, you click on save. Yeah, that's it. When you click on the save button, then the form is saved in the Ego database, and there's a message saying everything's fine and you've done the job. If you come back on the website later, you want to edit something from this deployment, you look for your deployment in the table below, click on edit, and you get your information back again, of course. So I would say the job has been done, but you can always have a look at your JSON file. So this is on the bottom of the screen. You can always edit the different JSON files, whether it's the deployment JSON file that gets all the metadata from the glider and the deployment, or the sensor JSON file. So when you edit those files, you can find some warnings. It's only because some fields are empty, but it's not blocking. And you can always edit in this JSON editor information if you like. You don't need to go back in the form. And this is exactly the shape of the JSON file needed by the Coriolis processing chain. It's also the same that OceanOps is using to upload information in its database. And you can do the same for the different sensor. You can unfold the different section and see what has been added. Well, you can download those files if you want to store it in your computer. And basically, you're done. The last step is to send the metadata by clicking on this button to Coriolis and to OceanOps. And so that Coriolis and OceanOps receive the information of a new deployment, and we can, each of us, process the information in the different database. So, yeah, thanks for watching. So I hope it was clear enough, and not too fast or too slow. Speaking on a video is always a bit challenging. So this came from the need to develop this tool came from the past. We face so much difficulty with Coriolis to get the metadata and organize the JSON file to process the data. So I think it will facilitate life of European glider users, but not only. Everyone that is willing to request Coriolis to process the data can use this form to make the metadata files. Sending the data to Coriolis is not made through Ego yet. It's always a bit complicated. It needs a bit of tuning, ad hoc tuning. So this is not something Ego it's not a service Ego is providing. but Ego can support, because we've tried that in the past, and there is existing tools that Ego can share. What would I? Yeah, last point that is very important. We are in a transition phase from Ego format to Ocean Glider format. But for the users of this form, this will have no impact. Maybe there will be a field or two added to this form. The list will change because it will be aligned with the Ocean Glider 1.0 reference control vocabulary. But for the users, it has no impact. It's as smooth as it can be. Yep, that's what I have to say. And if there is any question, I'm happy to answer.
Yes, thank you very much, Victor. It was really a great job of presenting at the same time as the video, and I can say that there was a lot of efforts that were put in this tool. It has been proof tested by a few groups, and it's still evolving, but now it's quite robust. But if you use it and there is a problem, you can of course get to Victor, to anyone of us, and we'll fix that. But normally it's becoming quite robust. Pierre?
Thank you, Victor, for this presentation. I think it was nice. I just have a question about the attribution of the WMO number. I'm not sure it was very clear for everybody what to get it.
Okay, so before I answer, I need to thank the people from Ego who developed this tool and Coriolis. We did this together, OceanOps, Ego, and Coriolis, and with the support of OGS, FMI, and the IMARPE, which is a Peruvian glider group, for the validation of the tool. I forgot to say that, so thanks, Yves. So to get the WMO ID, you go on OceanOps is the provider of WMO ID for any platform of the Global Ocean Observing System. So if you want to share your data to Coriolis or on the GTS or on Ocean Glider, you need a unique identifier for your glider that is delivered by OceanOps. And to do that, there is two options, whether you go on the OceanOps website under the Ocean Glider theme, and there is a button called request ID, and you request a WMO ID if your glider groups or glider program is already registered in the database. So that's automatic. It's very easy. It's only a few metadata needed to get this information. But if you're not used to that, you can always send a message to support@oceanops.org, and I got this message and do the job for you. Was it clearer?
I guess so. Thank you.
Any questions? Or everyone is just willing to try it directly for the next deployment? Victor, it was clear as possible. We have a hand raised. We have a question. Yes?
Hi, this is Tanga Prakash from India. So I have a quick question. So regarding this, this is only for real-time data processing. Is a delay time mode is also available? Is it audible?
Sorry, I was disconnected. I don't know if the question has been asked.
If it's it works for real time, and does it also work for delayed mode?
The JSON file the metadata file produced by this form is the same whether it's real-time or delayed mode. So I would say this form works for both. So you can, if the deployment is in the past, you can use it. That's fine. I don't know, Thierry, if you have something else to say.
Yes, data assembly center activity is to manage data that is transmitted in real time. But when a glider is recovered, the data processing chain has to be able to manage the data from the memory of the glider. And when delayed mode data from the CTD or another sensor is made available, it's the task of the data assembly center to accept this data and to merge it into to add it in the netcdf trajectory file, mentioning that this is delayed mode data.
Okay.
So yes, what is presented is both for real time and delayed mode.
Okay, I have another question. So regarding the data processing, so glider is taking the time from the GPS position. Is I'm correct?
Sorry, what coefficient is that?
The question is related to data processing. So glider taking the time from the GPS, correct?
So the glider data are distributed in real time on GTS, yes.
Yeah. So in case if glider is not coming to surface and unable to communicate with the satellite, but still glider is doing multiple profiles, which timestamp it will take?
The data is transmitted as vertical profiles. So each vertical profiles can be have a date and a position. And if the vertical profile was performed during in the subsurface activity, there is an interpolation of position of the glider. If the profile if there was no surfacing when the profile is complete, then we interpolate position from next and previous positions.
Victor?
Yes, I think the processing chain also has the capacity to use the internal clock. I mean, there is two options basically in the processing chain. I don't know what you are using in general, but you can use the interpolation of time between two GPS connection, or you can also use, if I recall well, the internal clock when the measurement has been made.
It is the location, the position that we interpolate, but we have
Yes. Okay.
We have the time of the profile.
Okay. So it's not only the GPS location and time that are used to create the record in the netcdf file. It's also the internal clock of the glider.
Yeah. Yes.
I think that was the question. Did we answer your question properly?
Yeah.
Ngao?
Yes. Yeah.
Okay, Laurent, can you try to speak, and hopefully there will be no echo.
Hear me?
Yes, but not anymore.
We can hear you, Laurent.
You are muted.
And normally you should hear you now.
Can you unmute me?
Here, no.
We hear you.
Là, c'est bon.
Okay, you hear me?
Yes.
Yes.
Okay, so Victor, do you have an assessment on how much glider deployment, have you been catching with your efforts since the beginning, either through Coriolis or the Australian or American data center? For sure, you don't know how much because they are known, but an assessment on this, some numbers maybe?
Victor, you're muted. If you want to.
So did not hear the question, probably.
Sorry, I got the question and I was muted. It's 2,687 at the moment. Do you hear the
267.
2687?
So deployment or gliders? No, much more.
Deployments. Yes, deployments. Gliders, I don't know. I cannot say right now.
But 267,000, no?
No.
2,600. This is what
2,600. Okay, perfect. Okay, thank you.
Deployments. And I
much
don't
more
have the number of different glider. I could, but it take time.
Okay. And do you have the time where the deployment between the date of the deployment and the time it enters either any GDAC or any repository? So meaning an assessment on how the users are willing to share in real time the deployment.
No, I don't have this number. It's something I would like to set up, but it's more complicated than when it looks.
Okay, thank you.
Thank you. I believe it's time to wrap up. It goes very fast, 1 hour. We're already 10 minutes behind. People are leaving. Thierry, Victor, if you want a last word, you can.
I'm fine. Thanks a lot for listening and attending.
Okay. Then I will thank you all for joining, even in this July time. Yeah.
And I would say, so send your deployment to whatever the DAC you are using, but try to send the information even before the deployment has started. And when the data are available, send the data as well. So
that's the overall message, is to send everything to Coriolis and OceanOps, and Ego will support with the tools for that. And I mean that if we manage to do that, that would be great. So thank you all for joining, and see you in the next one. And do not hesitate to ask for any questions, as always. And we have some good comments on the chat.
Bye-bye.
So, bye.